In this section, we're going to learn how to describe chemical reactions. All chemical reactions have two parts: the reactants, which is the stuff that you start with, and then the products, that's the stuff you end up with during the course of the chemical reaction. Every chemical reaction has this kind of representation. We have reactants on the left, and then we have an arrow, and we have products on the right. When you read a reaction, you read it from left to right. You read the reactants, and they're reacting together. Then when you get to the arrow, you say react to produce the products, and that's what's on the right-hand side of the arrow. In a chemical reaction, remember from chapter 2 that atoms aren't created or destroyed according to the law of conservation of mass. Now you need to show this in your chemical reaction by balancing it correctly. We'll talk about that in the next section. A reaction can be described in a couple of different ways. One is a balanced reaction, which we'll talk about in the next section, but there are a couple of other ways that I want to talk about in this section. A reaction can be described in a sentence where every item in the reaction is a word, such as copper reacts with chlorine to form copper 2 chloride. That tells us everything that happened in the reaction, but it's kind of long and it uses a lot of words. There are shorter ways to write this. One is a word equation, where we use some symbols in place of words to make it a little easier to write and read. Copper plus chlorine, arrow, copper 2 chloride. As you read this, you would just replace the plus and the arrow with words like and reacts to produce. Copper and chlorine react to produce copper 2 chloride. The arrow separates the reactants from the products, and it's always pointing to the products on the right-hand side. When you read an arrow in an equation, you read it as reacts to form, or yields, or produces. The plus sign, of course, means and there's a couple of other symbols I want to talk about. If you have a little s in parentheses after the formula, that means it's a solid. Like this FeS, that means solid iron. If you have a little g after the formula, it means it's a gas, like carbon dioxide gas. The little g tells me it's a gaseous carbon dioxide. An L after the formula means liquid. It's often written as a lowercase cursive L, but it could be a regular L as well, such as this, liquid water. If you have an AQ after the formula, that means aqueous. That means you had a solid, like solid sodium chloride, but you dissolved it in water. So now it's aqueous sodium chloride. It's a mixture of salt and water. If you have a double-headed arrow, one arrow going right and one arrow going left, or one arrow with two heads on it, that means it's a reversible reaction. We'll talk more about that in a later chapter. If you have a triangle on top of the arrow, that means heat is supplied to the reaction. You can have a triangle, which means you've changed the heat, or sometimes just the word heat is written over top of the arrow. If you have another chemical symbol on top of an arrow, it means a catalyst was used. Like PT means a platinum catalyst was used. So a catalyst is something that speeds up a reaction without being changed or used up in the reaction. You might remember enzymes from biology are biological catalysts in your body. They make chemical reactions happen in your body that normally wouldn't. You don't really have enough what we call activation energy to start the reaction. But if you use a catalyst like an enzyme, the reaction will happen at much lower energies. The third way we can describe an equation is called a skeleton equation. This uses formulas and symbols to describe a reaction. So in this example here, I have a word equation, and we're going to try to turn it into a skeleton equation. This requires a decent amount of work by you. You need to take everything that you learned from chapter 9 in your formula writing and apply it to this. So we have solid iron 3 sulfide. So we write Fe for iron. The Roman numeral 3 after the name iron tells me that it has a 3+ charge. And then the anion on this compound is sulfide. So sulfide is sulfur, and sulfur is in group 16, so that means it has a 2- charge. 1 3+ does not balance out 1 2-, so we need to crisscross those numbers, and we get Fe2S3. And we have a little S in parentheses after it to tell us that it is a solid iron 3 sulfide. It's reacting with gaseous hydrogen chloride, so I need a plus sign, and then it's time to write hydrogen chloride. So hydrogen is +1 because it's in group 1, and then chlorine is -1 because it's in group 17. These charges do balance, so no need to crisscross. We just need to put a little G after it to tell the reader it is a gas. And those two things are reacting to form. That means we need an arrow. So now we're talking about the products on the right. It's reacting to form solid iron 3 chloride. So Fe is iron again. The Roman numeral 3 tells me it's a 3+ charge. And chloride is chlorine in group 17, which means it has a -1 charge. Those charges don't balance, so again we need to crisscross the numbers. Fe3 or FeCl3. And it's solid, so we need a little S there. And hydrogen sulfide gas. So the and means we need another plus sign, and hydrogen again is +1, and sulfur is -2, and those charges don't balance, so we need to crisscross H2S. So there's our skeleton equation, Fe2S3 plus HCl arrow Fe3 or FeCl3 plus H2S. That tells the reader everything that's in those words, just in a more shorthand fashion. And yet we need to put a little G after that to tell us it's hydrogen sulfide gas. Okay, let's do another one. Hydrogen nitrate dissolved in water reacts with solid sodium carbonate to form liquid water and carbon dioxide gas and sodium nitrate dissolved in water. Why don't you pause the video and give this one a try. In your notebook, go ahead and try to write down all of the symbols for these reactants and products. Make sure you check your charges and crisscross when necessary, and don't forget to put the little symbols to tell whether it's a solid, liquid, or gas. Okay, let's see how you did. Hydrogen nitrate, so that's H+1, and nitrate, that is a polyatomic ion, so that's NO3, and that has a 1- charge. Dissolved in water, that means it's aqueous, so AQ. And it reacts with solid sodium carbonate, so plus Na, it's in group 1, so that's a +1, carbonate. Carbonate is CO3. It has a 2- charge, that's another polyatomic ion. Those charges don't balance, so we need to crisscross the 2, Na2CO3. And that is a solid. And it's reacting to form, so that means we need an arrow. Liquid water, that's easy, H2O, the little L. And carbon dioxide gas, that's also easy, CO2 with a little G. And sodium nitrate dissolved in water. So sodium again is +1, nitrate is NO3 -1, those charges balance. It's dissolved in water, so I need a little AQ for aqueous. And there is our skeleton equation. Okay, let's now try to go in the other direction. So if you're given a skeleton equation, you should be able to read it out loud. So here is FeS plus O2G arrow Fe2O3S. So all you need to do is do this, one compound or element at a time, and go left to right, and don't forget to say whether it's a solid or a gas. So this would be solid iron reacts with oxygen gas to produce solid iron 3 oxide. So the reason it's iron 3 oxide is because this oxygen is 2-, so that would be 3 2-, that's a -6. That means this side needs to be a +6. The only way that can happen is if iron is the +3 variety. Okay, let's try another one. We have solid copper, and it's reacting with AgNO3. That's silver, and then NO3, hopefully you recognize that as a polyatomic ion. You go to table E, that's nitrate. That's aqueous silver nitrate. And it's reacting to form solid silver, and then we have CuNO3 too. So this is a tough one. Copper can be +1 or +2. So we need to figure out which one it is. So NO3 is a polyatomic ion. This is nitrate, and it's on table E. And if you look it up, you'll see it's a -1. So I have 2 -1s here. This little 2 means I have 2 nitrates. So that's a -2 on this half of the formula unit, which means this side needs to be +2. So that means I'm dealing with copper 2 nitrate. So once again, solid copper reacts with silver nitrate dissolved in water, or aqueous silver nitrate, to form solid silver and aqueous copper 2 nitrate. All right, let's try one more. Go ahead and pause the video and give this one a try. Okay, here's the answer. Nitrogen dioxide gas reacts with a platinum catalyst. So when you get to this arrow and there's something over top of it, that means it's a catalyst. So you just need to find out what PT is using your periodic table, and perhaps table S, that's platinum. So when you get here, you just say platinum catalyst to produce nitrogen gas and oxygen gas. So let's wrap things up here. Equations are a way of describing chemical reactions. You should be able to interpret what's happening in a reaction in a sentence or a word equation or a skeleton equation. You should also understand the meaning of the symbols used in equations, and this is a skill that, although it's not tested directly on the New York State Regents, it's just something that you need to do when you're talking chemistry, when you're describing chemical reactions, balancing chemical reactions. Basically just saying anything that's happening in a chemical reaction, you should be able to describe it using either a skeleton or a word equation.